All right, so today we are going to talk about taking these rational expressions that we've been simplifying and applying them to equations and solving rational equations. And it's going to be a little bit like what we did with the complex rational expressions, the fractions in a fraction, and the same as what you did in Algebra 1 when it came time to solve equations with fractions in them, right? We would clear those fractions, right? So like 1/5 x plus 2/3 equals 3/5, right? We would take our least common denominator, which here would be a 15, and multiply every fraction by that least common denominator. Right? And then we would do some diagonal simplification. 15 will go into 5 will go into 15 3 times, leaving us with a 1 in the denominator. So we would just get 3 times 1, which is 3x. Same thing here. Get 10. Same thing here, and get 9, and then we would go just solve that equation. Well, it's going to be the same thing here. We're going to find a least common denominator and multiply everything by the least common denominator, dividing out our common factors, and therefore that should eliminate our fractions, and we should be good to just go ahead and solve whatever equation's left, right? That's the idea. So we're going to find our least common denominator. We're going to factor the denominators, find the LCD, multiply everything by the LCD, right? Now, when you're diagonally simplifying, remember that monomials can only simplify with other monomials, binomials with binomials, trinomials with trinomials, etc., right? Then solve, and then check for extraneous solutions. We talked about restrictions before, what values of x we cannot allow, and most of it is going to center around the denominator end up being 0 if you were to plug that solution back into the equation, right? We'll talk about those some more. Right? All right, so we're going to dive right in to this first one and look at this, and all of the denominators are factored. So all we need to do is go through and find our least common denominator, which is just x plus 4. Now, let's go back to our restrictions. What can we not let x be? And there are certain values that we don't want x to be, and most of it's because we don't want the denominators to be 0. We can't divide by 0. So we look, what values of x would make any of these denominators 0? And hopefully you recognize that that's -4, because -4 plus 4 is 0. Right? So when we solve our equation, as long as our solution's not -4, we should be fine. We won't have any extraneous solutions. Okay? All right, let's try it out. So we're going to multiply everything by x plus 4. Divide out these x plus 4s and we get x. Divide out these x plus 4s and we get 4. And then distribute the 2. Because that x plus 4 doesn't have anything to divide out with it. And now we just go solve, right? This is much easier to do than the original problem. Subtract x from both sides. Well, let's simplify first. Right? Subtract 12 from both sides, subtract x from both sides. You get -12 equals x. Since x is -12 and not -4, then we do have a solution, and it all works out pretty great. Okay? All right. Next one. Same deal. Find the least common denominator. All the denominators are factored. They're all monomials. So remember from our complex expressions conversation, we want to take the least common denominator with any numbers or coefficients, which is 2, and then the highest exponent of our variable, so x squared here. And we're going to multiply every fraction by 2x squared. Right? These 2's are going to divide out, giving us x squared times 1, which is x squared. Now, this 1x will divide out one of the x's in the 2x squared, leaving us with just 2x. So 3 times 2x is 6x, so minus 6x. And then these x squareds will fully divide out. Negative 4 times 2 is negative 8. Now we have a quadratic equation that we need to solve. It has a b term, so we can't use the square root method. So we've got to add 8 to both sides. Then we're going to factor. Set our factors equal to 0, but hopefully at this point we realize that our solutions are going to be 4 and 2. Now we didn't do our restrictions up here for our least common denominator. We need to remember to do that. X cannot equal, and so anything that we can plug in for x that will make any of these 3 denominators 0. And it's really any number that I can plug in for x that will make our least common denominator 0, and that right now is just 0. So, since 4 and 2, neither one are 0, either one are 0, we're good. Alright, you try. Find the least common denominator, multiply through by that least common denominator to clear your fractions, and then go solve the equation that's left. Stop the video. You can start it back up and see how you did. Okay? So there you go. The least common denominator is 3x. Multiply everybody through by 3x, which means that x can't be 0. Back up for a second. That means x can't be 0. That's the only value of x that would make our least common denominator 0. So anyway, we multiply through by 3x. We get the quadratic equation x squared minus 3 equals 2x. Get it equal to 0, set our factors equal to 0. We find that our solutions are 3 and negative 1. Neither one of them are 0, so we're okay. All right? Next one. We start getting into denominators that we have to factor in order to find our least common denominator. So first guy factors into x minus 3, x plus 2. Next guy into x plus 2, x minus 2. And then factor out a 2 for the last guy. Now, least common denominator is each factor taken from each denominator one time. So start here. X minus 3 is going to be part of that, which means that any other x minus 3 in any other denominator is already taken into account. Well, there aren't any other ones, so it's fine. We move on. X plus 2 is the next one to come to, which means that any other x plus 2 in any other denominator is taken into account, which means those guys. We don't need them again. And then an x minus 2. And then we have this 2. Okay? Now, I'd like to change the conversation like I did with the complex expressions. We know that anything that each denominator has in it will divide out with the least common denominator, which means that we're going to take the numerator and multiply it by whatever is left. In other words, multiply the numerator by whatever the denominator is missing. And so this first guy, this first x minus 2, will have to get multiplied by a 2 and an x minus 2, because that's what that denominator was missing from the LCD. The next fraction is missing an x minus 3 and a 2, so we get 2 times x minus 3. And the last denominator is missing the x minus 3 and the x minus 2, so multiply by that. And now we got to do a bunch of foiling and distributing and things like that. So we get 2 times x squared minus 4. Distribute this 2. X minus 3, x minus 2 multiplies out to x squared minus 5x plus 6. Distribute through. Again, another quadratic equation. There are some x terms, there are some b terms here, so we need to get it equal to 0. And just so I can keep my x squared positive, right? So 3x squared minus 2x squared is x squared. I've got a bunch of like terms over here I need to combine together. 2x and negative 15x is negative 13x. And then negative 6 plus 18 is 12. 12 plus 8 is 20. Okay. Now, we did not. All right, so I made a mistake somewhere. I know. I kind of felt like I was making a mistake somewhere. X minus 2 times x minus 2 up here is not x squared minus 4. Somebody should have stopped me. So x squared minus 4x plus 4 is how that multiplies out. So we got to try this again. My apologies, we'll fix it. So distribute 2x squared minus 8x plus 8. Now we want to subtract the 2x squared, add the 8x, and subtract the 8. So subtract the 2x squared, add the 8x, and subtract the 8. And our equation actually turns into 0 equals x squared minus 5x by the time you combine these guys. And then negative 6 plus 18 is 12, minus 8 is 4. Now we want to factor into x minus 4, x minus 1, and we solve with solutions of 4 and 1. Now we did not do our restrictions up here, so what can x not be? Well, anything that would make the least common denominator 0. That would be 3, or negative 2, or 2. And since none of our solutions are 3, negative 2, or 2, we can use them both. There are no extraneous. I was pretty involved. Had to do a lot of multiplying out there. Okay? All right. Next, factor. Find your least common denominator. First guy, you can factor out a 3. And then the second guy won't factor. The third guy factors into x minus 4, x minus 1. That means our least common denominator is 3, x minus 1, and x minus 4. Multiply the numerator by what the denominator is missing. All right, we get this. So multiply out. X squared plus x minus 2 minus 54 oh, that's x squared. Distribute the 3 combine like terms. Alright, now subtract the 3x squared over, subtract the 3x over, and add the 60 over. We'll get 3x squared minus 27x plus 60. Since it's a quadratic, we've got to get it equal to 0. You can factor out a 3 here. X squared minus 9x plus 20. And then factor down your trinomial into x minus 5, x minus 4. The 3 won't provide a solution, so we don't worry about that. The other two factors, though, will give us 5 and 4. We did not do our restrictions. What can x not be? Because it will make the least common denominator 0. It can't be 1 or 4. Well, we see down here that one of our solutions is 4. This is extraneous. So our only solution is 5. It's the only one we can use. Okay? Alright. You try it. Factor each denominator. Find your least common denominator. Clear your fractions and solve the equation that's left. Did you come up with 17 over 4? The least common denominator was x plus 3, x minus 2, and x plus 1, making our restrictions negative 3, 2, or negative 1. So, you can see the work there to get us to 17 over 4, which is a perfectly acceptable solution. So we should be in good shape. If you're not sure where that came from, come in and see me and we'll go through it. All right? A few more here to take a look at. Watch what happens with this guy. Same process. We're still going to factor each denominator, find our least common denominator, which here is going to be x, x plus 4, x minus 4. So we multiply each numerator by what its denominator was missing. And so this first one was missing the x plus 4 and the x minus 4. The second one was missing the x. But take a look. How might you get from the original equation down to this? Can you see what's going on? We're basically just cross-multiplying like a proportion from Algebra 1, right? That's going to happen every time you have a rational equation that's a fraction equal to another fraction. If you have one fraction on either side, then you can simply cross-multiply. Okay? That didn't work on the previous 6 because it wasn't one fraction equal to one fraction. It had one side of the equation had a couple of different fractions on them, right? So it wasn't going to work for those 6, but it actually does work here. You can just cross-multiply these guys. But again, it's only if you have a proportion, which is basically a ratio equal to a ratio, and a ratio is a fancy word for fraction, right? So anyway, we can go through and simplify, multiply out the left side, the right side, and then try to solve, subtract x squared from both sides. Divide both sides by negative 4, and x is 4. Now what we didn't do were our restrictions. And so 0, negative 4, and positive 4, any of those would make our least common denominator 0. So we can't use them. And look, it looks like 4 was one of those restrictions. So that means that there's actually no solution here. Okay? So make sure you're checking those restrictions. All right? Second one's the same deal. It's a fraction equal to a fraction. So I'm going to go ahead and just cross multiply. Makes this much, much easier and much, much quicker to work through. So distribute here. Multiply through here. And now we're ready to solve. Get it equal to 0. Factor, and our solutions appear to be 7 and 2, but we didn't check our restrictions. So that's going to be tougher because we're not actually coming up with the least common denominator. So make sure you check your restrictions for all of your denominators, period. X can't be 1 because it'll make that right denominator 0. That's okay. We got 7 and 2, so we're in good shape. All right, so try this last one with just cross multiplying. Make sure you check your restrictions and see what you come up with for the solution. Stop the video, start it back up when you're done. Did you get 0 and negative 15 for your solutions? I hope you did. You see the work there. If it doesn't make sense or you don't know what you did wrong, make sure you come in and get some help, okay? But that's it. So homework out in Canvas. Make sure you get that done by next time.